That doesn't make sense. Can you get it, Torrent? How are you?
Good. How are you?
You coming early?
Yes, sir.
Cool. All right. So let's start talking about who invent calculus. Do you guys know who invented calculus? Isaac Newton?
Yeah.
I don't know. Do you? I don't know. He's so who invented calculus? So calculus is invented by Isaac Newton. Okay, that's fair. But there's another person that no one knows. Like if you do like sports, you know, everybody remember the first place, nobody remember second place, right? But the second place in this case is have a major contributions. He's is a German guy. It's actually his name is Gottfried Limbus. Gottfried Limbus. Is it? Which is it? Are you German? You look it up? Okay. According to Sydney. Okay. Gottfried Limbus is a second person which is contribute something that we're gonna learn much later. It's called implicit derivative. So without his contribution, Newton cannot be as big. So Newton kind of stole all his work. You know how like some people are just more popular, more marketable, and Newton's like one of those person that's more marketable. Okay, so then what inspired Isaac Newton to invent calculus is back then he knows something about it. They invented calculus. They invented telescope in the 1600s, and so there was a person named Galileo. Galileo looked at start using telescope. He did not invent telescope, although I thought he invented telescope. We look at Wikipedia, it's not him. But he started looking through a telescope. He started looking at the sky and looking at things. Back then, Catholic Church thought that um, is geocentric. Do you guys remember what geocentric mean? What geocentric mean, Cameron? Earth is centered. But the Pope thought was the whole time the Pope thought was that way. And then there was someone says Galileo looking through a telescope says, I don't think that's right. I think the sun is the center of the solar system. In this system particularly, they cannot look too far away. They only know the solar system back then. So they find out that well, we are not the center. So Galileo, because of that, he got locked up in a prison. They call it back then. It's called excommunicated. If you learn European history, anybody taking European history before? You you did? Okay, so you'd probably learn about term about excommunication. It's basically they just lock up in a place and they do not allow you to publish papers and they say you can. They don't kill you. They just like and they don't like lock you in prison. They just find a place that's desolated from everybody else and then he start and just kind of let him rot in his life. Um, so Isaac Newton is also at the same time is also started using telescope. He started looking. I find out like if you take European history, that was one of my favorite class besides calculus in high school. Uh, my teacher is Miss Phillips' teacher. Um, his name is Mr. Herschel, and that guy is amazing. He knows all the side stories, like for example, like which king is gay, which queen has side person, and stuff like that. He knows every detail about everything personal life and stuff like that. Like you go into his class, you just listen to him talk about stories, and it's interesting, it's fascinating. Like Queen Elizabeth has like whatever affair with certain people. He knows every details. Um, that lay down. But back then, the scientists. Now the scientists are different. Most of the scientists are atheists right now. Back then, the scientists are all believing God, including Descartes. Everybody should know Descartes. What is his famous quote? Descartes. Nobody knows. Oh my God.
I think therefore I am.
Yes. Alex, you're pretty smart. Good job. I think therefore I am. Did you take European history?
No,
No? How do you know?
it's not like obscure.
Okay. Yeah, I think therefore I am. So that's Descartes. Descartes is also has contribution pre-calculus. So now Isaac Newton says he believed in God. He want to go to heaven when he died. So he look at the sky. He says, "Well, heaven's probably some location somewhere else." They didn't know better. They just look at, and they start to discover the planet is moving. No, one planet is moving. One day is here and one day is there. So he started curious about certain things. So let's just say you look at a planet that's moving, like this Earth, and other planets moving at an elliptical path, and this is a path, and so one day you see a planet is moving from this location to this location, like it changed location depending on second day. At the nighttime he visit, this is change location. So he says, well, I want to find the velocity of this planet. So that means you need to find how much it change from one point to the other points, because there's time difference, right? From today, tomorrow it's 24 hours. And then the planet is changing how much. And you can find the speed of that. So, and then he said, well, the speed is equal to the tangent line, which is the line here. Is also known the tangent line. Okay. And then, so he proposed like, hey, can anybody find out the tangent line problem? So calculus come up with the first problem. So the first problem is very well known as the tangent line problem. So he says, can anybody find out the equation of this line? So, or speed of this planet, which is the tangent. The second one is actually the area under the curve. So area under the curve. So it creates two problems. But before calculus, there was a pre-calculus that we're going to study last year. So what happened is AP College Board taking over the education of AP pre-calculus, which is they missing some very, very important element. When I teach pre-calculus about 5 years ago, we had to do something called limits. And you're gonna be like, we also did limit last year, but before limits, that's something before the calculus. So you needed this idea to start going to the calculus. So limit is one of the idea that we are missing. That's AP calculus. AP pre-calculus is missing. So you have to know the idea of limits. Does anybody can tell me what's the idea of limit? What does limit mean? You learned last year. What does limit mean? No. Okay. Yes.
Like how far you go or stuff.
You're not wrong. Um, not pretend that you're reaching that slowly approaching a place. Like slowly approaching a place. Let's pretend that I'm reaching the number 2 from 1.5, 1.6, 1.7, 1.8, 1.9. 1.95, 1.99, 1.999. We can approach that slowly. So this limit idea is very important. So now the first problem, the tangent line problem, and we say, okay, we're gonna solve. So in terms of what we learned in algebra 1, we say, well, slope of line is really easy. The tangent line is really easy of a straight line. So if I have a straight line, the slope is really easy to calculate because this is changing of y, this is changing of x, and that is the slope. The slope is easy. Where slope of this line is very easy. Is that okay? Now, the area is also equally easy as well. If I say today I want to find the area of another curve, you can say it was just a rectangle plus a triangle, which is also known as trapezoid, because later on we're going to learn something called trapezoid. So in terms of a straight line, that's fairly easy. But what Newton is curious, it's interesting in what is the curvy line, like a parabola or ellipse, mostly ellipse rather than parabola. So then you say, okay, well, what happened with the parabola? So what happened if you have something like this, and I want to know the tangent line? But I only have the function. So there's a function, some type of second degree function, some type of quadratic. Okay, ax squared plus bx plus c. But we don't know what we don't know. We want to find a slope at that particular point. I say at 5. We want to find a slope at that. So it turns out that it was a very difficult thing to do. And the tangent line, the area under curve for this problem is also equally, because this the curve is not a trapezoid. So the final area under the curve is also very difficult to do. So Newton proposed those two problems, but he's also the solver of those two problems. He solved those two problems. So he proposed it and he solved it. Let's talk about the first problem. Imagine that I have a line. I have a grid. And this is the function. And let's just say I want to know that this particular point right here, and I want to know the tangent line. I want to know the slope of this. I'm interested in the slope of tangent line. I'm interested in slope of tangent line. Now, I only have the function f of x. But is it possible to find out slope of this line? It's probably very difficult. So Isaac Newton says, hey, well, I don't have to know the slope of that line. First of all, you should ask me what does tangent line mean? The tangent line means it touched one specific point at that certain range of things. So within this range, that they only intersect exactly one point and just touch that point, just graze that point exactly at one point. And so you got a slope tangent line. And then he proposed as say, well, what if I create a second point right here? And we're gonna create a second point. So there's a red dot and there's a green dot. So I'm gonna call this coordinate as x, f of x. That's x and f of x. And we're gonna call this distance in terms of perspective from here to here, we're gonna call it h. Some type of distance is arbitrary. It could be 1, could be half, could be 0.1. but this is the small distance arbitrary is h. So let me ask you, what would be the coordinate of this point? What would be the coordinate of this point? If I define the bottoms h, the first point is x f of x, what would be the second point? No one can tell me? Give it a try. Yes.
H f of x.
Almost. You're not wrong. Yes.
X plus h of x.
Almost. Almost there. One more thing. Missing one more thing. So he says x plus h. This part is correct. What will be the y output? Cameron?
H of f of x.
No. Amelia? F of x plus h. Good. So that becomes a new coordinates. And in algebra 1, we can find slope of this green line. The slope of this green line is going to be like this. And this is, we're going to call it slope of secant. So he says, can we find a slope of secant? Slope of secant is equal to y2 minus y1 over x2 minus x1. You learned that in my test question. And that's why I asked you, can you find the slope? But in this case, we says we have two coordinates. Those coordinates as f of x plus h minus f of x over x plus h minus x. It turns out that both x cancel out. It's just h. Is that okay? The x cancel out. So that's the beginning stage. I find the slope between 2 points. Now, what we do is, remember, we have some tool before, calculus. We have limits. We pretend something can reach to something. We pretend this h can slowly decrease. Imagine h is going from here to here. We're going to slowly decrease from here to here. And we're going to create a second point. Sorry, my fault. It's going to be second point here. And it's going to be like this. And I'm going to decrease again. So if you realize this is still a secant line, like this. It's still going through 2 points. So we want to decrease so small where h is becoming 0. So it's decreasing. So the only way to do that with math notation is create slope of tangent line. And that's equal to limits as h approach 0 of fx plus h minus f of x all over h. When limit h approach 0, that becomes slope of tangent line. So the green line will slowly decrease until it changed to become the blue line. So when h approaches 0, that's going to become the slope of the tangent. Now, my graph is really half-assed. So how much time I have? What? 4 minutes? Okay, that's good. Okay, so I like this is you can go into Desmos and you can learn about the secant line and tangent line. And you click on this and you go to examples and then you scroll down to derivative or tangent line right here. See this point here? It starts at like the blue line or start at the green line and start decreasing. Do you see the slope there? MS, the M slope of secant, start decreasing. Do you see that? And eventually that's a tangent line over there. Eventually tangent line. I'll just use a different function. I'll use the x. And so it starts with this, right? This is a decreasing until you get very, very close. You can see that if it goes close and it be undefined, but you can get really close, it becomes a tangent. You can calculate the slope at that point. It's almost, it seems like reaching 2. But when it reaches 2, it's become undefined. So you can reach in there, you can say, well, the slope roughly at 2. Roughly at 2. And that's how they solve the first problem. Now you're going to be like, how do they solve the second problem? The second problem is area under the curve. It turns out this one has a very good thing here, example. It turns out there's a mathematician named Riemann. And I'm going to say x squared here. And so start with, let's say, for rectangle. We can say, let's find the area of rectangle. And you can calculate by, see this 4. So between 0 to 2, you can break 4 pieces. Each width of rectangle is 0.5. And you can go to the height and you can multiply and you add them. Now you can say, well, what if I increase 4 to what? 8. It becomes more accurate. You see that white area becomes less. 16 becomes less. 32. It becomes very little. I can say, in order to find the area under curve, I can say this go to 1,000 or 10,000, whatever, right? So I'm just let it run. And we'll stop like 9,766. So what if the rectangle can break to infinite pieces? There's still a discrepancy, but it's so small, it's negligible. And that's only 9,000 pieces. What if we go to 1 billion pieces, 10 billion pieces, 1 billion trillion pieces? In this 9,000 pieces, it's probably get down to like 5 decimal places accuracy. But anyway, that's it. Study for tomorrow test. And this is the introduction of calculus. Now there is a lot of TikTok video that talk about the guy with like Kanye or like Donald Trump is like teaching about derivative and integration. Those are good video actually. You get more welcome to find out and more. That's what I got. You already take today's lesson, so you can do it.
That's pretty much it.
Well, you have a test
Yeah.
tomorrow.
Trick.
Yeah, I don't know how much you remember trig.
No, I've been locked in with the other.
He's the other two.
Okay.
I'm locked in on trick.
Okay. So beginning class, people going over all that. So you can start with that, and then this part of the lesson you already know, so you can start going through all the questions.
And then lunch, can I ask you a few questions about the paper sheet you gave us?
Paper sheet.
Not the paper, but the
Tomorrow.
Yeah, the homework.
Yeah.
Sorry.
You can ask your friend here in the class too.
Alright.
Hey. So I see that the first test is not well, and I see you're trying, you're putting effort, and I don't mind that. And you will stick around, right?
Yeah, of course.
Okay.
It wasn't even like doubt or anything of staying in the class. I did
I'll be
pretty
back to
bad.
see.
I did pretty bad, and I did try. I'm not gonna say I didn't try. I did all the homework, and even the summer packet, I did it as well. Like Shantae were very close. Shantae, Emma, Ramonka,
Those are great kids.
and Miranda. We all like had a little study session, but math just has never been my thing.
What do you
but
want to major in?
I want to be a dentist, so I'm gonna have to
All right. Well,
try anyway.
so I have seen kids like you. They fought their way through. And last year, you can see it. I don't know if you know Astrid.
I know Astrid.
Okay,
yeah.
Astrid is that type of student that just doesn't know anything, but she
Yeah.
fought, and she fought all the way through to the end. She got a 4 on AP exam. Same things like Gabby Russo, same thing like a lot of kids. They all got 3s and 4s.
Yeah,
So if you keep on fighting and don't, are you senior or junior?
I'm a senior.
Okay. If you keep on fighting, I will maintain a certain grade. Okay, so that way it doesn't hurt your chances. But the best I can do is a C. The best I can do. I won't let you hang below that, but you have to show me all the time. You come in tutor and try to get better. And if I see enough work, then I might move a B. But I'm not gonna be judged based on your test score, but you have to go back and understand everything.
The issue with that, just because of this first semester, is cross country. So I know I talked to Katie about it because I know she did calc, and I was like, "How did you like do it?" And she said that like every Wednesday she would try to come in when there wasn't practice. So I'm gonna try.
You
to do
can
that
also
same
come at
way.
lunch as well if you ever need it.
Okay, cool.
Okay.
Thank you.
All right.
I was going. I had a secret one.
Vincent, did you do your homework?
Yes, I did actually.
You did? Thank God, bro. God for really God doing his homework.
All right, bro. 90%. You don't really know.
It's so lucky you're
Like,
like, bro.
still know when like Apple 5, like
You think you got options choosing which one's gonna help the other us or no? Sure. Oxygen, you, man. She's going to have everything here and she's not.
Oh, you're putting in work yesterday in the group chat. You're putting in work yesterday in the group chat. Dang,
Where is Leo, bro? I swear I want
What?